Radical Dude here, and today we're going to learn about graphing the trig function sinX. Now, it travels in a wave, and you guys know what waves are, right? It travels like that. It travels like this. These are waves. What other waves do you know? You know the ocean wave travels like that. Believe it or not, sound, my voice, is traveling in a wave. And the other waves you know are this one. I don't know if it's hello or goodbye. You say goodbye maybe, but I say hello. Now, if you leave it like this is pretty messy. It looks like you're tagging up on the board. You might get your teacher mad. Well, we don't want that. We want to organize it. So here's how we do it. We come over here, we start with our great Cartesian plane. I'm going to just do this right here. This is X. This is Y. Right? And we're going to take this sine wave. I'm just looking at quadrants 1 and 4 right now. We're going to take the sine wave and it travels like this. Just like that. Try to make these two the same area. I know it's hard to do. I'm not that good either. But these are supposed to have the same area underneath. Okay? Now what we want to do is we want to label it. I'm doing y equals sine x. So, what you do is, you see over here I have a high point, then I have where it crosses the x, then I have a low point, then I have back where it crosses the x. I want to mark these. So I'm going to put a dot here, a dot here, a dot here, and a dot here. Okay? Now, we have 1, 2, 3, 4. This wave on the sinX is the distance it takes to complete this cycle is 2 pi. It's going from 0 to 2 pi. We don't use degrees in this. This is 360 degrees. It's going all the way around the circle and then back again. And when you plot it out, it looks like this. What we have is we have 1, 2, 3, 4 pieces. So I take the 2 pi and I divide it by 4. And that leaves me with pi over 2. So I just count by pi over 2's. That's it. This is 1 pi over 2. This is 2 pi over 2. This is 3 pi over 2. And this is 4 pi over 2. I labeled it. Now all I have to do is reduce where I can. Well, 2 pi over 2, these 2's cancel, and this is just pi. 3 pi over 2 is fine, 4 pi over 2 cancels, and this is just 2 pi. So you really only need, you can get rid of that, and get rid of that. There it is, pi over 2, pi, 3 pi over 2, 2 pi. That is good. Now, we want to find how high up it goes. Well, we're doing y is sine x, and the range of it is from 1 to negative 1. That is your range. So what we're having is this distance here. If you take half of this distance, you get what's called the amplitude. This distance right here is called the amplitude. And it's the same as this distance right here. This is the maximum turning point. This is the highest you go. This is the minimum turning point. This is the lowest you go. And that is y equals sine x. So I will write it right here. Y equals sine x. But what if I wanted to graph y equals 2 sine x? Well, what changes is this first number here, the coefficient's called the amplitude. That changes. Light sometimes travels as a wave. When you see these colors, you're looking at different wavelengths. But if I change the amplitude on one color, I just change the amplitude, it changes in brightness. It gets more bright or less bright. It can get duller or really intense, depending on this amplitude. Now we're going to change it to 2. So all you have to do is come up here to 2 and come down here to -2. these points are still going to be the same. So what you do is to go to 2. Now I'm up here, and I'm touching here. And from here, this lower point, I'm going down here, and then I'm touching here. So I really go like this. Up, and then I go down, right? Sometimes in life, it's easier to go down. And then back up. And that is y equals 2 sine x. Okay? And remember, this travels forever. So it just keeps going and going and going. And it can go also back in the negative area. It can travel. Okay? But this is how it does it. They both need 2 pi to finish the entire ride. It's going to take you 2 pi to get there. Alright? Now let's look at this one. Let's change it to sine 2x. Well, now the 2 in front of the x is the frequency. How often is it occurring between 0 and 2 pi? It's always that distance. So when I look at it like this, I'm not going to put the 2 pi yet because I don't know where I'm going to end up. But you have to do the ride twice. So pretend it's a roller coaster. You're like, whoa, that's once. Now you do it again. Whoa, that's twice. Try to make those areas under these curves all the same. It's supposed to be the exact same. So this is 2 pi, and this is 0. Now how do I mark these? How am I going to mark this? Well, I'm going to do it this way. I'm going to put a dot, 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 like duck, duck, goose. Dot, dot, dot. How many dots do I see? I see 1, 2, 3, 4, 5, 6, 7, 8. So I take the 2 pi, I divide by 8, and I get pi over 4. So now I just count by pi over 4s. This is 1 pi over 4. This is 2 pi over 4. This is 3 pi over 4. This is 4 pi over 4. This is 5 pi over 4. This is 6 pi over 4. This is 7 pi over 4. And this is 8 pi over 4. Now I reduce the ones I can reduce. Pi over 4 is fine. But 2 pi over 4 I can reduce to pi over 2. I reduce this to pi over 2. 3 pi over 4 is fine. 4 pi over 4, well these 4's just cancel and I'm left with just pi. This is 5 pi over 4. 6 pi over 4 reduces to 3 over 2. So this is 3 over 2 pi, or 3 pi over 2. That's 7 pi over 4. And 8 pi over 4 reduced to 2 pi. And there you have it. That's that so far. And if I just wanted to change something to a +2, oh, I forgot the amplitude. Here's the amplitude. There's your range. That's the range that it goes. Okay? Now, what happens if I were to add something to this? I'll just show you really quickly. If you add something to this, just say I added 5. The only thing that changes now is that you're going to be, this number here is going to be at 5. So on the graph, this changes to 5. Now you're still going up 1. So what number does this become? This becomes a 6. And now you're going down 1. What does this become? This becomes a 4. And I have the same graph. And later on, maybe in another video, we'll talk about phase shifts, horizontal shifts. But that's the basics of graphing y equals sine x. This has been Radical Dude, and I hope I was able to teach you something.